this is one question that I get almost every time I make a pitch to any one of my prospects. I kind of go talk to somebody, say, your refresh cycle is up, you need to refresh your Wi-Fi to a newer generation. The first question that I hear is, should I deploy Wi-Fi 6E now, or should I really wait for Wi-Fi 7? And this is something that has been sort of, on my mind a lot. And it's becoming very difficult to answer this question because people are at various stages of the refresh cycle. They might have infrastructure that supports it, does not support it. They may need Wi-Fi 7, they may not need Wi-Fi 7. Wi-Fi 6 may be good enough for them. There are a lot of these things that need to get answered before you can sort of give people a sense of, will they benefit from moving to Wi-Fi 6E now? Or will they, does it make sense for them to wait for Wi-Fi 7? And I've been trying to answer this question, so I thought I'll just, share my experience of how I'm trying to answer this question to my prospects. So this is what I'm going to talk about, right? Just a very quick brief of the evolution of Wi-Fi and why it makes sense to go to Wi-Fi 7, what are the features and benefits. I'll be really short on this. And then I will go into the challenges in realizing the benefits from Wi-Fi 7. As things exist now, I'm sure things will improve as time goes on and the chipsets become better and the implementations become better. But what are the challenges to realizing Wi-Fi 7 benefits? And then what are the considerations that people should look at if they are upgrading from Wi-Fi 5 or Wi-Fi 6 or wherever they're at right now. Wi-Fi, all of you probably know this, but I'll just make a very quick sort of introduction here, right? Until now, or until Wi-Fi 6, the focus has been in improving peak rates, right? Between B and AG, we got 5x sort of increase in peak rates. From AG to N, we got 11x. From there to 11AC wave 1, we got another 11x. But then Wi-Fi 6 actually brought in the spectrum efficiency, so we did not see too much of a peak rate improvement, but there was a huge improvement on throughput from a single cell or a multi-cell deployment. So while the peak rates did not grow, the kind of application that it enabled was amazingly large, just because of the spectrum efficiency that Wi-Fi 6 or 11AX got into the system. And now, with Wi-Fi 7, the focus has actually shifted back to peak rate growth. So if you see all the proposals in Wi-Fi 7, and I believe this is just to sort of compete with 3GPP in some way, where IEEE has been focusing now on improving the peak rate rather than the spectral efficiency that we saw improved during Wi-Fi 6 or 11AX specifically. So what are the features, what are the outcomes of these features, and what are the benefits that people should expect from Wi-Fi 7, right? So all of you have heard this, I'm just going to repeat this, right? These are the 6 primary items that will show you some benefits, the features that are getting added, right? 320 megahertz channels, 4096 QAM, 16 spatial streams, multiple RU allocations per client or per station, improved preamble puncturing, where you could puncture a very small part of the spectrum, and then multi-link operations. So these are the 6 items or features within Wi-Fi 7 which are useful. And here are what the outcomes of each of these features is going to be, right? You're going to get extremely high throughput. You're going to be able to easily deploy in very high dense environments. It will provide you low latency and very high reliability. And then what people should expect out of this is you'll be able to enable next-gen applications, and you will improve end-user experience. And the way these tie in, and this is a little bit complex, but again, you will have the slides, so you can take a look at this later, is that all the blue lines or all the features that are marked with blue will add to extremely high throughput and so on and so forth. And all of these things put together really help you to enable next-gen applications and improve the user's experience. Now, while this is all sort of good and nice, really the applications that really benefit from Wi-Fi 7 are low latency applications like AR, VR, or gaming, right? Being able to deploy in very high dense environments, and things that actually require very high reliability and ultra low latency, like remote surgery, things like industrial automation, some precision controls, etc. So this is the promise from Wi-Fi 7. Though at least I personally have to see these in action, but this is the promise that comes from Wi-Fi 7. And let's see, when should people really try and sort of, deploy Wi-Fi 7. So the first thing is that we saw the 6 features, right? And these features are nice in terms of the specifications, but there are challenges in actually realizing benefits from these things, right? So if you look at things like the 320 megahertz channels, right? In 6 gigahertz, yes, you've got 3 channels of 320 megahertz that you can, allocate, but there is channel availability. 5 gigahertz is just not going to be possible to run 320 megahertz channels, right? The power consumption is going to be high because you're going to be using a much wider band. There are challenges in building amplifiers, filtering capabilities that are flat over the entire 320 megahertz band, right? And then the channel conditions vary, and if you're using a 320 megahertz band, sometimes you'll be able to transmit on the entire band, sometimes you will not. While the specs allow for it, and you can sort of shift each TX op to a lower bandwidth, but it's a challenge. And obviously, if you're running 320 megahertz channels, you will see a lot more interference from neighboring APs. If all APs start operating 320 megahertz channels, you will see a lot more interference happening. 4096 QAM. To be honest, I think this is a completely marketing-driven feature. It requires 40 dB, right, SNR. Now tell me, when do you get 40 dB SNR? When you are sitting right next to your access point. In a typical deployment, when do you sit right next to an access point? Never, right? And this is not going to work in non-line of sight. This is nice, it looks good on paper, it looks good when you're in a lab, and you can show it to work, but in real life, at least I personally feel this is never going to work. Anyway, but that's what it is, and it's in there, so people will implement it, especially AP vendors like us will implement this. 16 spatial streams, right? We saw in a presentation earlier, right? People are not getting like 6 antennas right in an AP. Do you expect them to get 16 antennas right in an AP? Just not happening, right? It's going to be really complex to deploy that. Other thing is that one of the key things that happens is that it reduces power per chain. And when that happens, you are going to get very little SNR. And that is something that's not going to sort of be really good in a typical deployment. And then there's a lot of sounding overhead to make sure that this works right. MU-MIMO has never worked. And this is also something that I feel is going to be a huge challenge to deploy in a real-life situation. The MRU allocations is something that is really, really interesting, where you can allocate multiple RUs in a single TX op to the same station. And this can improve the throughput for every station. But there is hardware complexity into this in terms of creating the chipsets that will be able to do this. There is signaling overhead again. And if you have ever seen the 802.11 BE spec, which specifies how the signaling is done, it goes into I think about 32 pages, right? Just the signaling specification. It's not going to be easy to implement that. And then there's going to be interoperability challenges in terms of how do clients actually implement this, and is all of this going to work? Improved preamble puncturing. Clients, I have not seen any client really currently implementing this, so there's going to be a challenge in terms of clients implementing this. And in terms of multi-link operations, this is the most promising feature, if I can say. This is the one feature that I'm personally looking forward to. But this requires very tight coordination between the links, because now you're going to have upper MAC and lower MAC, and there's got to be a lot of coordination there. And obviously, the power consumption will go up because you're going to have multiple radios transmitting at the same time. More important for the client side rather than the AP side, because AP is connected to a power source. Clients are not, they're working off battery. But if they're going to operate multiple radios at the same time, that's going to be a challenge. So these are the challenges in realizing the benefits from Wi-Fi 7. There are other challenges as well. One big challenge is going to be that the AP cost per AP is going to go up, you like it or not. There is particularly complex software that will go into the radios, and you will need more radios. Remember that with 6 gigahertz, you can't throw away 2.5 right now. I see so many places where 2.5 is still used. For example, in my office in Santa Clara, we've got printers which are like $8,000 to $10,000 each. They're still running a 2.5 gigahertz, 2.4 gigahertz radio. I'm not going to throw away that printer just because I want to move them to 5 gigahertz or 6, right? There are monitors that are running 2.4 gigahertz. All of this equipment is still very good. It's not going anywhere. And then you have 5 and 6. It's just more radios. And people are talking about thread. People are talking about matter. People are talking about HADM to be operated from the access point. Just means more hardware in the AP. And then obviously to run all of these applications that we need to run from the AP, you need a faster CPU. That's going to cost you more, which also means more storage, both volatile and non-volatile storage in the AP. And then to top it all, you need a faster Ethernet, a faster PHY to carry all that traffic back. And that adds to the cost of the access point. And then with all of this in there, you need better power management, better heat management. So all of this is going to push up the cost of the access point when it comes to Wi-Fi 7. The next challenge that I see, especially enterprises sort of experience because of this, is that because now you'll be moving from a 2.5 or a 5 GBE PHY to a 10 GB PHY, and then move PoE from 30 watt to 60 watt PoE. You need switches that have a much higher power budget. Because if you had 20 APs connected to a switch, now you've got the same 20 APs, but all of them are drawing 60 watts power. You just need a higher power budget per switch. This actually trickles down into the power budget that goes into the rack. Right? Each rack is supplied with, like in a data center, you will see them, connected through 2 redundant supplies, and each of the supply has a limit. So, that is going to go up. You need faster uplink speeds, because even though no AP is going to give you a sustained 10 Gbps throughput, there will be bursts. And to handle those bursts and make sure that you're not creating a bottleneck at the egress from the switch, you will need a much higher uplink speeds from the switches. And you'll obviously need better cabling. Even if you had Cat6 cabling done, you still, you can only go 55 meters if you're doing 10 GB. If you're using Cat6, you will have to go to Cat6A. And Cat6A is particularly more expensive than Cat6 cabling. The other interesting thing that I did was I was just looking at the expectations of how many units are going to ship over the next few years. This is information from the 650 group. Now these are all client chips, and this is what is going to ship. Now and what I did is I converted their data into a chart that says what is going to be the Wi-Fi device population, assuming that every device goes in, has a life of about 4 years. Okay? Now if you look at that, you will notice that Wi-Fi 6E will really take off in 2025. It's a very, very small slice in 2024, even in 2024. And if you look at the Wi-Fi 7, people are not expecting that to become significant in 2026. So there is still some time before which you can realize the benefits of Wi-Fi 7 in enterprise deployment. And then again, Wi-Fi 5 still continues to linger on. It's going to continue to be there. So you should expect a mixed mode deployment. You're not going to get a greenfield environment with Wi-Fi 6 and above. So here are the considerations that I usually look at to advise people on should they move to Wi-Fi 6E or should they wait for Wi-Fi 7. We look at the refresh cycles. We look at the application considerations, what applications they're using, what is their client ecosystem, and when they're planning to refresh those, and then what are the infrastructure considerations in terms of switching, in terms of the other sort of infrastructure that will support your Wi-Fi at the back end. So what I did is to kind of try and make this easy for myself. I created a flowchart, which is what I'm going to share, right? So if you look at the Wi-Fi refresh cycle, it's a real easy question to ask, right? Is the Wi-Fi refresh cycle due? If it's due now, and if you are running Wi-Fi 5 or legacy, the customer should immediately, consider upgrading to Wi-Fi 6E, because you're going to see immediate benefits. You're going to be sort of, your investment right now will give you results right away. But if your refresh cycle is not due right now, or you are already running Wi-Fi 6, then we'll look at some of the application considerations in terms of what applications you are running. So if you look at the application considerations, right, the first question you have to ask is that your current Wi-Fi deployment, is that sufficient to run the applications that you're running? If it is, right, and if your current generation is Wi-Fi 5 or older, then you should look at the infrastructure considerations, which will come into the next slide. But if your current Wi-Fi is not good enough to support your applications, no brainer, go ahead and upgrade to Wi-Fi 6E right away, right? Now, if you're running Wi-Fi 6 already, right, then you should ask yourself the question that, do you run applications today that require extremely high throughput or very low latency? If it is, then let's look at the client considerations as wait, and you could move to Wi-Fi 7 when it's mature enough. Now, looking at the client ecosystem considerations, right? If your client generation that you are running on the client is mostly legacy, right? And if your client refresh is imminent, you are going to upgrade your laptops, your other clients that you have in the enterprise, then you should consider upgrading to Wi-Fi 6E right away because you will see the benefits. You don't need to wait for Wi-Fi 7. But if you are not going to refresh your clients right now, and if you're going to keep them around for a year and a half, 2 years, then you should consider waiting for Wi-Fi 7. And if your current client generation is already Wi-Fi 6, if you already have devices that are running Wi-Fi 6, you might as well move to Wi-Fi 6E right now. And then finally, when looking at your infrastructure, right, you should think about, do your switches support, at least 5 GB with 60 watts right now? If they do, and if you are upgrading to Wi-Fi 6, you're fine. But if either of this thing is either no, that you don't have switches that support at least 5 gig or 60 watt power, then is your switching cycle due, switching refresh due? If the switching refresh is due, then might as well upgrade your switching, but make sure you have upgraded to a level which will support Wi-Fi 7. And if not, there's a loop here, but loops are unavoidable in most decision-making trees. So you go back and check your application considerations. And based on what your application considerations are, you decide to move to Wi-Fi 6 or 6E or stay at Wi-Fi 7. So this is the sort of decision matrix that I use. So I thought it might be interesting to share this with you because this is something that I keep getting almost on every pitch that I make to end customers. They always ask me this question, so that's where I am. Thank you.